Welcome to my tutorial on converting fractions into decimals. This is a really important topic because we're going to be seeing it in a lot of different places. We're going to have to be able to know the equivalencies between fractions and decimals, and we're going to have to order fractions and decimals from least to greatest or greatest to least. Let's go ahead and get started. The first thing we need to know is, what does this fraction mean, 3/4? Well, when we're changing it into a decimal, we need to look at this line as divided by. So we would read it 3 divided by 4. And that would mean the 3 would become the dividend and the 4 would be the divisor. An easy way to remember this is by the horse and cowboy. The horse is traveling along and bucks off the cowboy, throws him into the house through the roof, and then he just trots up outside. So it's a little silly way to remember that the top number, or the numerator, always goes inside the division problem. Let's go ahead and work this out. We just said that the 3 goes on the inside. The top number always goes on the inside of the problem, and your denominator becomes your divisor. You're going to quickly see 4 cannot go into 3. It goes in 0 times. So when we have a regular fraction like this and we're dividing, we're always going to need to add a decimal and a 0. And then we need to put our parking spaces just like we would with division with decimals. We bring the decimal right up above where it's at. So we just said that 4 cannot go into 3. It goes in 0 times. 4 times 0 is 0. We subtract and get 3. Just like a regular problem, after you subtract, you bring down. So you would bring down that 0. You do not bring down the decimal. So now we're looking at 30. How many times can 4 go into 30? 4 can go into 30 7 times. 7 times 4 is 28. We subtract and get 2. Now, when we get to this point, we have a number here. It's not a 0. So what that means is we have to continue on with our problem. So what we're going to do is we're going to add another 0, a parking space, kind of extend our line here, and we're going to bring it down. And what you'll notice is we've talked about how when you add zeros to a whole number after a decimal, it does not change the number. So 3 or 3.0 or 3.00, it still means 3. This is just a way to help us divide. 4 goes into 20 exactly 5 times. 4 times 5 is 20. We subtract and get 0. Now when we get a 0 after we've subtracted, we call that a terminating decimal. That means it stops. We don't need to go any further. We don't need to add any more zeros or parking spaces or anything. We're finished. So that means 3/4 equals 0.75 or 75/100. Let's do another example of a terminating decimal. 5/8. Our numerator is going to go inside, just like that. 8 can't go into 5, so we need to add our decimal 0, and we need to put our parking spaces and our decimal. 8 goes into 5 0 times. 8 times 0, 0. Subtract, you get 5, and you bring down your 0. 8 can go into 50 6 times. 6 times 8, 48. Subtract, you get 2. So again, we have a number here. We need to continue by adding a 0, adding a parking space, and bringing it down. 8 can go into 20 2 times. 2 times 8 is 16. You subtract and you get 4. Since we still are getting a number after we subtract, we have to continue. So we're going to add a 0, add a parking space, and bring it down. Now, 8 goes perfectly into 40 5 times. 8 times 5 is 40. Subtract, and you get 0. So here's another example of a terminating decimal. We had to go a little bit further, but we finally got that 0, so we know that we're done. 5/8 equals 625 thousandths. Now, let me show you an example of a problem that's a little bit different. Here we have 1/3. So we're going to go ahead and put our 1 on the inside and our 3 on the outside. We know 3 can't go into 1, so we need to add our decimal and 0, our parking spaces, and then we can start. 3 goes into 1 0 times. It will not fit. 3 times 0 is 0. Subtract. You get 1, and you bring down that 0. 3 can go into 10 3 times. 3 times 3 is 9. We subtract, and we get 1. When you get a number after you subtract, you need to continue on. Add a 0, add a parking space, bring it down. 3 can go into 10 3 times. 3 times 3 is 9. You subtract, you get 1. You might start to notice that we're having a little trend here. If I add another 0 and a parking space and I bring it down, I get 10, and 3 can go into 10 3 times, and 3 times 3 is 9, and you subtract and you get 1. So if you see this pattern forming, you have what's called a repeating decimal. A repeating decimal goes on and on and on. That's why I put the sign for infinity. It will go on forever and ever. It will not stop. Once you've seen that you have a repeating decimal, you can go ahead and stop. There are 2 ways that you can write this. One way you can show it is by writing 0.333 ... And this ... is called an ellipsis. It just means it's going to go on and on and on. It won't stop. Another way to show a repeating decimal is to put 0.3 and then a line over the 3. That signifies that this 3 will repeat on and on and on. You have to be able to recognize both ways of showing a repeating decimal. Let's go ahead and do one more example of a repeating decimal. The 4 will be going on the inside and the 6 will be going on the outside. We're going to add our decimal and our 0 and our parking spaces. 6 can't go into 4. You multiply and subtract, you get 4, bring down the 0. 6 can go into 40 6 times. 6 times 6 is 36. We subtract and we get 4. We need to add a 0, add a parking space, bring it down. 6 can go into 40 6 times. 6 times 6 is 36. Subtract and you get 4. Here again, if we were to continue on, we would get 40 again. We would say it goes in 6 times and get 36. So this is another example of a repeating decimal. So 4/6 equals 0.666 ... or you could say 0.6 repeating. Let's go ahead and go over the rules and I'll give you some practice. The first thing we need to remember when we're converting fractions into decimals is to put the numerator, the top number, inside the division problem. Setting up the problem correctly is half the battle. Next, you're going to add a decimal, 0, and parking space. And then you're just going to divide like a regular decimal division problem. We're going to continue to add those zeros and parking spaces until A, you get a 0 when you subtract. That's that terminating decimal. Sometimes it only takes 1 division, sometimes it takes 2 or 3. Or you notice a repeating pattern. If you see that repeating pattern, you can go ahead and stop. Here's some practice problems. Go ahead, pause your video, work these problems out, and then play to see if you got the right answer. And here are your answers. You'll notice the first 2 are terminating decimals. 3/5 is equal to 6/10, and 9/12 is equal to 75/100. When you got to 1/6, you notice the 6 was the one that kept repeating. So I just wanted to point out, if that's the case, you only put the line over the number that's repeating. So it would be the 6 in this case. Or you could write it 0.166 ... your ellipsis. Thanks so much for watching this tutorial. I hope it helps, and I'll see you next time.